Have you ever wondered what the most spectacular event in the universe might be? It's a display that outshines entire galaxies, a spectacle of light and energy on an almost incomprehensible scale. This is the universe's grand fireworks, a supernova. A supernova is not just an explosion, it's the explosive death of a star. It's a celestial event of such magnitude that for a brief period, it can outshine all the stars in its host galaxy combined. A supernova is not just a grand spectacle, but one of the most powerful events in the universe. In this journey, we'll decode the mystery that is a supernova. We'll break down this complex phenomenon into simple, understandable steps. We'll explore the life and death of a star, the birth of a supernova, and its profound significance in the cosmic world. So, buckle up as we dive deep into the cosmic world of supernovas. To understand a supernova, we first need to understand the life of a star. Stars, these magnificent celestial bodies that light up the night sky, all begin their lives as nebulae, vast clouds of dust and gas. Over millions of years, these nebulae collapse under their own gravity, forming a dense core that ignites to become a main sequence star. These stars are colossal spheres of searing gas, predominantly hydrogen and helium. The heart of a star is a fiery furnace, where temperatures reach mind-boggling levels. Here, nuclear fusion takes place, an atomic reaction that converts hydrogen into helium, releasing enormous amounts of energy in the process. This energy is what makes stars shine so brilliantly. Stars spend most of their lives as main sequence stars, but as they exhaust their hydrogen fuel, they expand into red giants or supergiants. These behemoths can be hundreds of times larger than their previous size, a final grand stage before the end of their life cycle. Now that we know how a star lives, let's explore how it dies in a spectacular supernova. When a star has used up all of its nuclear fuel, it's time for it to bow out in a spectacular fashion. Picture a star that's been burning bright for billions of years. It has been a beacon in the darkness, a cosmic lighthouse guiding the way. But as with all things, there comes a time when the star's light begins to dim. It has exhausted its nuclear fuel, the very source of its luminosity. Without this fuel, the star can no longer resist the inexorable pull of gravity. It begins to collapse under its own immense weight. This isn't a slow, gentle process, but a rapid, violent contraction. As the star collapses, the pressure and temperature at its core increase dramatically. It's like a pressure cooker that's been left on the stove for too long. The pressure builds and builds until it reaches a critical point. The star's core becomes so hot and so dense that it triggers one last round of nuclear fusion. This final fusion, far more intense than any that came before, releases an enormous amount of energy. This energy creates an outward pressure that is so powerful, it overcomes the force of gravity that was causing the star to collapse. The result is an explosion of such magnitude that it outshines an entire galaxy. This is a supernova, a celestial fireworks show on a scale that's hard to comprehend. But this isn't just a spectacle for us to marvel at. The elements created in the supernova are scattered across the universe, seeding new stars, planets, and potentially life. Every atom in our bodies, the air we breathe, the ground we walk on, all were once part of a star that ended its life in a brilliant supernova. So there you have it, the birth of a supernova. But what does this mean for the universe? Stay tuned to find out. Because as you're about to discover, a supernova is more than just a dazzling display. It's a fundamental part of the cosmic cycle of birth, death, and rebirth. A supernova is not just a beautiful spectacle, it plays a crucial role in shaping the universe. You see, when a star explodes, it doesn't just fizzle out and disappear. It actually becomes a celestial factory of sorts. During the explosion, the star releases a vast array of elements into space. These elements, such as carbon, oxygen, and iron, get scattered across the cosmos, seeding the universe with the building blocks necessary for the creation of new stars, planets, and possibly life itself. But that's not all. The death of a star can also give birth to some of the universe's most intriguing phenomena. The core of the exploded star can collapse under its own gravity, forming a neutron star. In some cases, the core can collapse so much that it forms a black hole, a point in space where gravity is so strong not even light can escape. So next time you look up at the stars, remember the spectacular journey they're on, and the grand finale that awaits them.